Hello, welcome back to our channel. Today we have a special training for you. Sometimes I'm asked about which language is best to create your programs. Some other times I'm asked how to put it up together. Then, to answer your questions, please follow us along. In the first part of this video, we will be talking about precisely these two questions. When we talk about automation, there are always options. In OpenBAS, we have two main contenders. So, are you ready to rumble? Introducing you in the blue corner with more than 50 years in the market, PLC ladder language programming, used worldwide by major automation manufacturers, well understood by electricians and engineers. And in the challenger in the red corner, the script language programming, featuring plain English, easy to read and write style, with multiple language support championship belts, and backed up by legions of faithful coders and programmers. And the referee, an OpenBAS and ex-controller with years of experience with these two contenders. On the day-to-day basis, we are presented with challenges. The customers have what we need, problems and money, and we have what they need, building automation controllers and the expertise needed to solve their problem. When things get nasty and we have to get going, we have to choose. And as the old saying goes, there's more than one way to skin a cat. Just by the way, I love cats and dogs and have my own pack at home. So then, let's get to the meat. You have a customer who has a nice, good-looking home. He's clever and savvy with technology, but lacks the means or the details on how to automate his house. So he calls you and starts talking about his great ideas, like turning on the lights when the doors are opened, spinning the fan depending on the temperature. Then he starts adding more and more things, schedules, timers, test options, and so on. So yes, it's the time of the day just fine for some head scratching. So first, let's identify all of our objects. The inputs that will take the information into the process, the outputs that will be our means for controlling the process, and the actions, or as we call them, the program. So ring the bell and we have the first round of our fight. The first punch comes from the blue corner by the PLC with a software equivalent of the electrical diagram, showing us that if any one of the doors is open, the lamp will be on. Just look at that style to invert logic, using normally closed magnets in the doors that when the door is closed, they are open. Don't panic. All that can be done also in software. Now comes the back punch from the red corner with a style jab as an argument, in an easy readable statement that just has what is needed. Which one you like the best? Just the start of the fight, so just enjoy the show. Now then comes round two. The first punch comes again from the PLC, showing us that beyond the standard Boolean logic, it is full of features, such as function blocks, which are easy to program and parameterize. And then comes back the script with its plain text response, showing us in an easy way how the speed of the fan that will be run by a proportional control will be set up with a process variable, set point, proportional band, and some other features to make it easy to follow. Of course, we will be adding more and more as we advance through the training, but this will be in the second part of the video. Before we go into more detail into the programming, let's take a pause in our fight and talk a little bit about the hardware. In OpenBAS there is a variety of options to use and a common software to program that, regardless of the size of the controller, is always the same. Let's discuss the hardware features available for you as a programmer. Every program has available for its use 80 universal inputs that are split as 40 analog and 40 binary inputs. And OpenBAS controllers are available in sizes from 0 up to 24 universal inputs. Then comes the outputs. 70 outputs are available to the programmer. Also, both flavors and analog and digital are available. There are controllers that range from 0 on up to 21 digital outputs, and from 0 up to 4 analog outputs. But wait, what if you need more? The COM ports come to the rescue. You can add more inputs and outputs of what a single controller can offer using the communication ports. Any NX controller has 50 additional remote points that, using any of the available communication channels, can expand the number of inputs and outputs, and even more so, adding a memory expansion grows the capability by 420 additional input and output points that can be accessed through the remote points. However, in your PLC ladder language or EasyScript programs, you are not only limited to hardware inputs and outputs. You also have software. So let's start with the PLC instructions themselves. Each PLC controller has 3 PLCs with 400 instructions each. The script language at the end also generates PLC instructions that are what the controller natively executes to make the program run. Also available to you as a programmer, there are a bunch of software objects that are free for you to use and that are stored in non-volatile memory and persist even without power. And finally, as any program always needs a place to store frequently changing pieces of information, the RAM offers things such as bit registers for your Boolean equations, float registers for your math and analog processes, timers, and the real-time clock. All this information that could be overwhelming at first, but is very well documented in both the EasyScript programming manual as well as the OpenBAS programming manual that you can download from Mercom's webpage. Now that we mentioned that the first step was identifying your inputs and outputs, let's do exactly so. Here, we'll be using System Design Studio. The first thing we did for creating a PLC program is defining upfront the inputs and outputs to be used. So here in System Design Studio, the first thing we need to do is go here to Values and Trends, select Names. I already have created them for you, so you don't have to do it one by one. Here we have the temperature, which we'll be using in the second part of our video, which is an analog input, door 1, which is attached to binary input channel 1, door 2, which is attached to binary input number 2, the test button, the lamp 1, and the lamp 2. If we want to add or delete or anything we need to do, just can simply here come to Insert, add the name of a new, let's say we have a third door, so we will add door number 3. Door number 3. We will select, it will be a binary input, and let's select the channel that we have not used so far, so it will be channel number 5, and we just hit here Save, and we will see that the next door has already been created here on top. If we want to delete this variable we just created, just select it here, click in this checkbox, and put delete. It will be asking you if you want to do that. You just say OK, and the variable is now gone. Now here in the logic section of System Design Studio, I have already pre-created the program for you, and we will analyze each rung of the ladder program that we have created. So in the first step, first check the state of 2 doors. Here we have 2 comparators that are comparing door 1 and door 2 and storing the results of each comparison in result bit 240 and 239, which we call the stack. Then the next step is to test if either one is open. So here we have an OR instruction that either one of the results of the previous instruction gets compared and the result gets stored here. Then if both are closed, we have the jump instruction, which will jump down here, and in that case both lamps will be off. Otherwise, if the jump doesn't happen, then it will turn on the lamps. At the end also there's another jump instruction that we will skip these other 2, and we will get to the end of the program, which basically what does, it gets you back to the beginning, and this will run forever. Okay, once again we will go to System Design Studio and show you how to use the PLC editor. So here in PLC we are selecting here the logic of System Design Studio. We have each one of the ladders wrong. If we want to let's say we want to delete this end instruction, we just do so by clicking here the delete. We can add another instruction. Let's say we want to add an OR instruction. We just drag it and click it here, And then we can add the parameters. So basically here we can select here, this is the binary input number 1. This should be again the binary input number 2. Select channel number 2. And we select here where the result will be stored, which in this case is the result bit number 1. We click the OK checkbox here, and automatically you will notice that the input, if we hover on top of the door 1, which is a label, will be hovering, will be showing you the basically the parameter here. This one doesn't have any label, that's why it's not doing anything. If we just want to delete this instruction that we just added, we just delete here. Keep in mind that anything you add or delete, it happens online. So anything you add or remove will instantly affect your program. If we analyze here a little bit, here we have the ladder Boolean instructions, which are standard Boolean instructions. Then we have math. Also we have comparison instructions. We have others where we have instructions such as label, timer, jumps, subroutine, and end instruction, lighting groups, output assignment, multiple assignment, totalizers, proportional controls, air handling units and rooftop units, hour counters, alternate and parallel instructions, in range and out of range instructions, start and stop instructions, limits, the PID, which is a very powerful function block, a proportional stager, a leader calculator, staggered start and stop, and special instructions. If you follow up us in the manual, you will see basically how to set up each one of these function blocks. It's not really that difficult. You just have to add the functional block. Let's suppose we want to add here a start and stop instruction. Just drag it here, and here you just basically fill up the parameters. If you don't like it, well, you just can fill up here a leader calculator, and you just put the parameters. There are complex instructions such as the PID that have a lot of parameters to set up, but basically it's just like follow the lines. It has a lot of parameters. You just have to set them up and you're done. So now again we will go with the challenger. We already presented you how to do it in the PLC. Now let's go with the script. So in the script you basically do plain English programming. Here we are using Notepad++, which has the added benefit that it has syntax highlighting. So basically you can use your favorite editor. So first thing we have to write our program, and then I will show you how with SDS you can compile and download to the controller. So analyzing this program, the first thing we have here, and it's optional, we can create a name for your controller. Also, you can add comments, and you can remember yourself and others what you are doing. This is also optional, but a good practice to add a lot of comments. Add a lot of comments for your code, because when you come back 1 year from now, you will hardly remember what the program was written for. Then, after adding the name of the controller and the comments, let's create or define aliases to an input, output, or software object and make your program easier to write. So in PLC, we saw how we have to first create the names and then create the instructions, because otherwise it's hard to follow just by remembering the input and output names. So here we are creating aliases. With the define instruction, we are defining that the binary input 1, it's referring to door 1, binary input 2 to door 2, and also for the outputs, we are defining here binary output 1 is lamp 1, binary output 2 is lamp 2. It doesn't matter in the order that we just create them. It's just a matter of fact that you can write them anyway. You can even mix them all together. The next part is to write your logic implementation. You can use again the LT6631 Easy Script manual for your syntax, and here we can see, and it's really very straightforward. If the door 1 is open or the door 2 is open, then the lamp 1 will be on and also the lamp 2 will be on. Otherwise, or else, the lamp 1 will be off and also the lamp 2 will be off. Here, this is a single line. However, we have broken that into vertical line to make it easier to read by using the backslash. You will see, note a backslash here, another backslash down here. At the end of the line, you don't put it. That will signify that it's the real end of the line. And of course, we need the end instruction. When the controller finds the end instruction, basically it starts all over. It goes to the beginning of the program, and repeat forever until the controller is powered. Okay, now we will have a real example of how to configure your program using EC Script from within System Design Studio. You right click here in your controller and you select Configure from Script. The first thing you have to do is open your folder, so choose your location. In this case, my location is here in OpenBAS project, PLC versus Script. I select the folder. When that is done, I just click here in the Edit button. It sometimes takes a little bit of time the first time it opens. So once we open Notepad, basically System Design Studio opens Notepad for us and sets up different things. First, it selects the language, so you will see here OpenBAS EC Script, and we will open our script here, and you will see it doesn't have the syntax hiding. We just select it from here. Now you will see it's basically this is text, so you can edit any way you want. It also opens for us these examples. It opens a workspace, so in the examples, anything we don't remember how to do, let's say how to set up a proportional control, come here. Also doing the syntax highlighting, we can see the proportional control here we were talking previously. This is just text. You just can copy and then paste the information here, and basically that is the way to add more code to your program, but we don't want this at the moment. We will just delete it, and when it's ready, what we have to do is basically save the file, and when we save the file, we close here, and then we click Start. When you click the Start button, usually you will have to select what you want to load. The new version automatically detects what you need to load. You don't have to choose it manually. You just click Start and the process begins. When you click Start, text is converted to the instruction, then it's loaded to the controller. It takes some time because it's loading the labels, it's loading the program. It takes anywhere between a couple of seconds to a couple of minutes, depending on how many segments, how many things are being downloaded to the controller. When it's ready, it's finished. You see right now it's loading the PLC. We're done. Basically, we're doing converting text to PLC instructions. It tells us it's ready. So now we are done, and whatever we have changed here, you will see the changes here. So let's do something. Let's modify. I will just here with Control plus and Control minus, you can basically increase or decrease the font. I will add a third door. Okay, I will copy these. I will select here that binary. We already have used 1, 2, 3, 4, so I will make here that binary input number 5 will be the third door. Once I do this, I just copy here and add another option. If door 1 is open and door 2 is open, and I'll put sorry, or you see as soon as I type the color changes, or door 3 is open. So we will be adding. I really like to align everything horizontally and vertically so it's easy to read. Now we are done. We just save here. Once we save, we go again to Configure from Script to System Design Studio. I select my folder. Oh, I see it has been changed. So I select PLC versus Script. Select the folder. I just put Start again. And when I put Start, because I added labels, the labels will be created again. It's also loading some additional information. And when it's finished, we will come back to it when it's finished. So we see now it has finished loading the script, and we should, when we go back to the logic editor, we should see that new third door. So it's door number 1, door number 2. Oh, here it's binary input 3. The labels were not updated, but however, we can see how everything has been changed. Now in the OR instruction, we have 3 terms. Here we have the 3 comparisons. Then here we have that third term added here. And that's the way you go. It's really that simple. If we want the name to be correctly shown again, we go here to names. We see that the door number 3 has been added here. We just have not updated. And when we go back to logic, Let's close this window. Out you see there already door 3 is there, and when you hover on top of it, it's showing you it's using binary input number 5 as the channel. When we create software, it's an iterative process. So we see here basically we come with the analysis of the problem, we do the design, we do the implementation, and we do the testing, but it's really not a line, it's a circle. So here we see we start with the planning, then we do the analysis, then we do the design, the implementation, testing, and integration, and then we do maintenance. We keep adding things, we keep changing things, and again and again and again. This is the end of the first part of the video. Thank you. And the second part, we will see how to create the analog process, how to control the fan, and how to keep adding things. Thank you for following us.